Deep learning is a type of machine learning and artificial intelligence, AI, that imitates the way humans gain certain types of knowledge. Deep learning models can be taught to perform classification tasks and recognize patterns in photos, text, audio, and other various data. It is also used to automate tasks that would normally need human intelligence, such as describing images or transcribing audio files. Join our community of AI enthusiasts by subscribing to our channel for exclusive updates and insights. Deep learning is an important element of data science, including statistics and predictive modeling. It is extremely beneficial to data scientists who are tasked with collecting, analyzing, and interpreting large amounts of data. Deep learning makes this process faster and easier. Where human brains have millions of interconnected neurons that work together to learn information, deep learning features neural networks constructed from multiple layers of software nodes that work together. Deep learning models are trained using a large set of labeled data and neural network architectures. Number 1. Why is deep learning important? Deep learning requires both a large amount of labeled data and computing power. If an organization can accommodate for both needs, deep learning can be used in areas such as digital assistance, fraud detection, and facial recognition. Deep learning also has a high recognition accuracy, which is crucial for other potential applications where safety is a major factor, such as in autonomous cars or medical devices. Number 2. Deep learning neural networks. A type of advanced machine learning algorithm, known as an artificial neural network, ANN, underpins most deep learning models. As a result, deep learning may sometimes be referred to as deep neural learning or deep neural network, DNN. DNNs consist of input, hidden, and output layers. Input nodes act as a layer to place input data. The number of output layers and nodes required change per output. For example, yes or no outputs only need 2 nodes, while outputs with more data require more nodes. The hidden layers are multiple layers that process and pass data to other layers in the neural network. Neural networks come in several different forms, including the following: recurrent neural networks, convolutional neural networks, ANNs and feed, forward neural networks. Each type of neural network has benefits for specific use cases. However, they all function in somewhat similar ways by feeding data and in letting the model figure out for itself whether it has made the right interpretation or decision about a given data element. Neural networks involve a trial and error process, so they need massive amounts of data on which to train. It's no coincidence neural networks became popular only after most enterprises embraced big data analytics and accumulated large stores of data. Because the model's first few iterations involve somewhat educated guesses on the contents of an image or parts of speech, the data used during the training stage must be labeled so the model can see if its guess was accurate. This means unstructured data is less helpful. Unstructured data can only be analyzed by a deep learning model once it has been trained and reaches an acceptable level of accuracy, but deep learning models can't train on unstructured data. Number 3. How deep learning works. Computer programs that use deep learning go through much the same process as a toddler learning to identify a dog, for example. Deep learning programs have multiple layers of interconnected nodes, with each layer building upon the last to refine and optimize predictions and classifications. Deep learning performs nonlinear transformations to its input and uses what it learns to create a statistical model as output. Iterations continue until the output has reached an acceptable level of accuracy. The number of processing layers through which data must pass is what inspired the label deep. In traditional machine learning, the learning process is supervised, and the programmer must be extremely specific when telling the computer what types of things it should be looking for to decide if an image contains a dog or does not contain a dog. This is a laborious process called feature extraction, and the computer's success rate depends entirely upon the programmer's ability to accurately define a feature set for dog. The advantage of deep learning is the program builds the feature set by itself without supervision. Initially, the computer program might be provided with training data, a set of images for which a human has labeled each image dog or not dog with meta tags. The program uses the information it receives from the training data to create a feature set for dog and build a predictive model. In this case, the model the computer first creates might predict that anything in an image that has 4 legs and a tail should be labeled dog. Of course, the program is not aware of the labels 4 legs or tail. It simply looks for patterns of pixels in the digital data. With each iteration, the predictive model becomes more complex and more accurate. Unlike the toddler, who takes weeks or even months to understand the concept of dog, a computer program that uses deep learning algorithms can be shown a training set and sort through millions of images, accurately identifying which images have dogs in them, within a few minutes. To achieve an acceptable level of accuracy, deep learning programs require access to immense amounts of training data and processing power, neither of which were easily available to programmers until the era of big data and cloud computing. Because deep learning programming can create complex statistical models directly from its own iterative output, it is able to create accurate predictive models from large quantities of unlabeled, unstructured data. Number 4. Deep learning versus machine learning. Deep learning is a subset of machine learning that differentiates itself through the way it solves problems. Machine learning requires a domain expert to identify most applied features. On the other hand, deep learning understands features incrementally, thus eliminating the need for domain expertise. This makes deep learning algorithms take much longer to train than machine learning algorithms, which only need a few seconds to a few hours. However, the reverse is true during testing. Deep learning algorithms take much less time to run tests than machine learning algorithms, whose test time increases along with the size of the data. Furthermore, machine learning does not require the same costly, high-end machines and high-performing GPUs that deep learning does. In the end, many data scientists choose traditional machine learning over deep learning due to its superior interpretability, or the ability to make sense of the solutions. Machine learning algorithms are also preferred when the data is small. Instances where deep learning becomes preferable include situations where there is a large amount of data, a lack of domain understanding for feature introspection, or complex problems, such as speech recognition and NLP. While deep learning is incredibly powerful, it does have its limitations. One major drawback is its hunger for data. Deep learning algorithms require large amounts of labeled data to train effectively. For example, if you want to teach a deep learning model to recognize different types of cars, you'll need thousands or even millions of images of cars labeled with their respective types. Gathering and labeling such massive datasets can be time-consuming and expensive. Additionally, deep learning models may struggle with tasks where labeled data is scarce or difficult to obtain, limiting their applicability in certain domains. Another limitation is the need for substantial computational resources. Training deep learning models often requires powerful hardware such as GPUs, graphics processing units, or TPUs, tensor processing units, and significant amounts of time. For complex tasks or large datasets, training can take days, weeks, or even longer, depending on the resources available. This requirement for computational resources can be a barrier for individuals or organizations with limited access to high-performance hardware. Moreover, deploying deep learning models in real-world applications may also pose challenges in terms of computational efficiency, especially for tasks that require real-time processing or run on resource-constrained devices like mobile phones or IoT, Internet of Things, devices. Number 5. Potential applications of deep learning in the future. Currently, deep learning is used in common technologies, such as in automatic facial recognition systems, digital assistants, and fraud detection. Deep learning is also used in emerging technologies as well. For example, it is used in the medical field to detect delirium in critically ill patients. Cancer researchers have also started implementing deep learning into their practice as a way to automatically detect cancer cells. Self-driving cars are also using deep learning to automatically detect objects such as road signs or pedestrians. And social media platforms can use deep learning for content moderation, combing through images and audio. In conclusion, deep learning is a groundbreaking technology that mimics the way humans learn, enabling computers to perform complex tasks with remarkable accuracy. It has become an essential tool in various fields, from data science to artificial intelligence, revolutionizing how we collect, analyze, and interpret vast amounts of data. However, deep learning also comes with its challenges, including the need for substantial amounts of labeled data and computational resources. Despite these limitations, the future of deep learning looks promising, with ongoing research and applications emerging in diverse domains. As technology continues to advance, deep learning is poised to play a pivotal role in shaping the future of artificial intelligence and transforming the way we interact with and utilize data in our everyday lives. Join our community of AI enthusiasts by subscribing to our channel for exclusive updates and insights.